Okay, so on to part five. So in part one, we covered one group questions, so like sample to population. Um, and within part one, where there were four types of questions that we covered. Parts two to four, we covered two group questions, right? So sample to sample or population to population. And within those parts, we covered the six separate types of questions. In part five and in the later parts, we'll be covering questions that contain multiple groups and or multiple variables, right? So to give that, I guess, more meaning, we use an example, right? So, for example, does the make of a car determine its average speed, right? So in part five, you'll probably get data like this, whether through CSVC or CSV or just displayed as like a picture on the question, right? So as you can see here, this is similar to data that we had in part 4, but in this case, instead of just Honda and BMW, we have three more makes, so Ford, Maserati, and Tesla. On top of that, we also have three driving conditions, or I guess scenarios. So you have the highway, city, and residential, right? And so with all the information you learned through the previous parts, how would you solve a question like this that has multiple groups, right, and multiple conditions? Well, right now you can't, but that's what this video is supposed to show. Alright, so within this part 5, there's going to be three general types of questions, right? One's going to be a question with data, one's going to be a question with no data, and one's going to be a standard deviation question, right? This is just general. There's obviously going to be some questions that are bits kind of in between, but these are just generally what you'll find. So on to the data question. So the important part is that your data, when downloaded, must be in table form, not stacked. So if your data is already in table form, then you're good to go. You don't really need to do anything to it. If it's not and it's in stacked form, then you'll have to convert it to table form. So you'd use this formula. So the name is just the whatever name you want your tabled data to be. And you just use the table function, the name of your data, and then your whatever columns you want to be contained within the table. So your column 1, 2, or whatever. So in this case, for the example, I just named my table data EX, and then yeah, inputted the car.table, which is the data name, and then put columns 2 to 3. And just to make this a bit more sense, I chose 2 to 3 because the first column was a useless column. It just contained the number of rows, right? And I didn't need that. I just want the speeds and the brands, right? And the conditions. So yeah. If your data, let's say, I don't know, has 4 columns and 2 of them are useless, like let's say the last 2 columns, 3 and 4 are useless, then you would go 1 colon 2, right? And let's say, I don't know, you wanted to reverse the order, you could do 3 colon 2, right? You can do a bunch of stuff. So basically you can play around with that, but as long as your data looks something like this, right? That, looks like a table, right? Then you're pretty much good, all right? So yeah, once your data looks like this, then you could actually move on to solving the question, right? So you'll be using the Pearson's chi-squared test, or chi-squared, I don't know, I call it chi-squared. And yeah, you literally just do chi-sc.test, then brackets data, whatever that you called your table, comma, correct equals f. That's it. It'll give you your x squared, which is your test statistic. It'll give you the degrees of freedom, and it'll also give you your p-value, which is generally that's what most of these questions ask anyways. So generally, once you do that, you're pretty much done. But occasionally they'll ask for, say, the expected values, right? And so an important thing you should do when you're doing this test is to name this test. So you can name it cheese.test, or you can just name it whatever, like A, just to make it quick. But name the test, right? And then if it does ask for expected values, you can just do the name of your test, $, and then expected. And then it'll give you the expected values in a table format, right? So yeah, so if the question does ask that, then you can do this formula. And then also if you need your critical value, you just use QChisk, your alpha, your degrees of freedom, and then your then just do lower equal f. And your degrees of freedom you'll get with your Chisk.test, right? So yeah, easy, right? And then for your no data question, it's pretty similar, but the key thing is obviously you don't get a CSV or any file to download and to use in R. So there's two ways you can do this. One is you can do these equations by hand, which that's basically what R does. R basically is doing these, you know, the formulas, but all you have to do is just type in the code and it does it for you. But theoretically, you could do all this by hand and just use your own calculator. But obviously, pretty time consuming. So the next option is you make the table in R, right? So if we go back to this table right here, if we want to essentially put this into R, we're going to have to use a matrix function, right? So for this example, you would use this formula basically, right? So you have the name of your table, then you have matrix bracket, C bracket, your data, and then you have your end column by row, right? And so to kind of break this down, we can start with the data. So as you can see here, if we just look at the very beginning, we can see that the first three numbers are 102.3, 13.4, and 40.1, right? And if you look at the table, you can see that that corresponds with the first row from left to right. So 102.3, 13.4, 40.1, right? It's the same. If you go to the next number, it's 124.8, which is the second row's first number. So it's basically like, not really snake, but it goes from left to right, top to bottom, right? So that's how you'd input the data. All right, so essentially you want to start from the top left, and by the end, you should have the bottom right number, okay? And to contextualize the end call and biro. So end call is essentially how many columns you want, right? So since this table has 3, we want to have 3 columns. So we put end call equals 3. Another way you can look at it is that the first 3 numbers will be in the first row. The next 3 numbers will be in the second row, all right? So if we only had city and highway, then we would put 2. So the first 2 numbers would be the first row, next 2 numbers would be the second row, blah, 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 right? Make sense? And then biro equals true basically just means that the data we're inputting is going by row. If you wanted to, you could say biro equals f and input your data top to bottom, so like 102.3, 124.8, but then you'd have to change the way how you input the data. So yeah, in any case, just input your data like this, kind of just follow this example, and then obviously just change how many columns you need, right? The rows doesn't matter because it's based off the columns, right? And so again, your data should look like this. One little caveat though is that you won't get the names of your data. You'll just get like, I don't know, random, they'll be named something like brackets, comma, 0, bracket, comma, 1, something like that. So you won't get the names, but it doesn't matter. As long as you have the data and it looks, similar to whatever picture you have on your question, then it's good enough. And then, same way you'd solve your question the same as the question with data, because you essentially made the data, right? So same thing, same formulas, simple. And then for the standard deviation question, it's a bit different, well, a lot different actually. You will essentially need the sample standard deviation, the sample size, the population standard deviation, and then your alpha, or significance level, right? And so to get your test statistic, or your x squared, you'll still be doing the Chisk test, chi-squared test. And so, so let's just start with the test statistic. You gotta get your degrees of freedom multiplied by brackets of your sample standard deviation squared divided by your standard deviation, or population standard deviation squared, right? And once you do that, all you need to do for your p-value is just do your p-chisk test statistic and then degrees of freedom. and that's it. And then obviously depending on the upper-tailed or two-tailed, you can change it. And then, yeah, if you're also asked for the critical value, again, just do qchisk, your alpha, degrees of freedom, and then edit it to whether it's an upper-tailed or two-tailed question. Alright, and generally that's all you need to do. Now, again, on the off chance you're asked for a confidence interval, you would do a formula, or the formula is right here. They're basically both the same. It's just the only difference is 1 minus alpha or not, right? So the lower bound would have 1 minus alpha, and then upper bound would just have alpha, right? And then, yeah, that's pretty much it for part 5, right? Last thing for this type of question was that your data should be normal, all right? So obviously they're going to ask the question. It's assumed that the data is normal, right? Because obviously you couldn't solve it if it wasn't normal. But if for whatever reason they asked, can you solve this question if the data wasn't normal? Then the answer would be no, you can't. Your data needs to be normal. But I don't know, that's not really too important to solving the question, right? But yeah, anyways, that's pretty much part 5. I will say there's one type of question you might find, which would be a expected versus observed values question, but I've rarely seen that question, and it's kind of similar to like the standard deviation question, so you should be fine. If you need help, you go ask like your instructor or something, right? But yeah, that's basically it. I guess we're past halfway onto part 6 next. Yeah, okay.